Hey folks, so this is going to be the third video in section 8.1, but this is the first of several videos dealing with the ambiguous triangle. This first video is going to be mostly theory, so if you could go down to the page where it starts with the ambiguous triangle, 8-5. Again, this is a theoretical video. After this, I will do some example videos that deal with the law of signs in the ambiguous case. All right, let's just talk about a few things that I want to remind you of. First thing is that remember that your sign value has to be between -1 and +1. I know that's not what this says, but think about this. In a triangle, our thetas, our angles, will not be negative angles in a triangle. We understand that we can have negative angles when we're looking at the coordinate axis, but we won't have negative angles in a triangle. So for that reason, then, all of our sign values have to be between 0 and +1. If my sine is actually equal to 1, you think about the unit circle, sine is equal to 1 at 90 degrees. So then this is going to indicate that our theta is a 90-degree angle and my triangle is going to be a right triangle. The second thing to remind you of is that, here it is in English, supplementary angles are going to have the same sign value. So think of it like this, okay? I've got the unit circle here, and I have two values, 2-degree angles on the unit circle marked 30 degrees and 150 degrees. These guys are supplementary angles because they add to equal 180. Not only that, though, they have the same sign value. The sign value is 1/2 for each of those because the y value is the same. So in geek language, the sine of an angle is going to equal the sine of its supplement. This is going to come into play when we have to use sine inverse, so just kind of keep that in mind. The third thing to remind you about is that the small angle has to be opposite the smallest side, the large angle opposite the large side, the mid angle opposite the mid side, and that's what I have here. Small opposite small, medium opposite medium, large opposite large. So just remember these three concepts that we have talked about previously in class. All right, now let's talk about the description of the ambiguous case. And the first thing that I want to point out to you, sorry about that, is that all of these have 3 known pieces of information. We are told what angle A is, we are told what side A is, and we're told what side B is for all of these situations. So I want you to just look through the pictures for a moment and notice that for the first 4, angle A is an acute angle. Okay, so just to understand, angle A is an acute angle. You're told what angle A is. In this particular case, this is a generic chart here, so we don't actually know what A is, but in a question, you would know what the measure of this particular given angle is. Opposite that is side A, and so you'll notice that opposite side A is a really short A, opposite side A is a medium size, opposite side A is longer in both of these cases, okay? So we have either, I like to call it Goldilocks and the 4 bears. So we have really short, a medium size, and 2 instances of really long. So you got the really, really long, and then you just have sort of long. And then we also have here where angle A is an obtuse angle. Again, the side opposite is side A, and you either have a really short one or a really long one. We'll go through each of these individually. The other thing that we're handed is side B. So notice that side B is adjacent to angle A. It is next to angle A. So just understand that. All right, now here's all the possibilities for the ambiguous case. The first thing, and let me just say this really quickly, I'm calling this H. This is the height of my triangle. We understand that if I were to just look at this right here, which this is not my actual triangle, but if I included this H as part of a triangle, I have a right triangle, and so the sine of angle A is equal to the opposite over the hypotenuse, or H over B. That's what I have written right here. If I were to isolate the side H, that would equal B times the sine of A. And so I'm calling that the height. So every time you may see H here, this is just the height of the triangle. And mathematically, we can find the height of the triangle by doing B times the sine of A. All right, so here's the possibilities. Let's only look at the ones that have an acute angle. All right, so I'll zoom in here just a tad. All right, so the first thing to notice is that in this first case, we have side A. It's shorter than the height, and you can see that on our picture. It's shorter than the height, but not only that, it's also shorter than side B. All right, so side A is shorter than side B. I just want to look at several of these here. On this one, side A is shorter than side B. We've got that here. Side A is shorter than side B. Go to the fourth option. This one here, side A is shorter than side B. So I have three options where side A is shorter than side B. There's only one option where side A is longer than side B. So just kind of keep that in mind. All right, so let's go back up to this one right here. Side A is shorter than side B. I noticed that it doesn't really matter how many times I swing this side around. I'm never going to be able to make a true triangle out of this. And here's what's going to happen. When you apply the law of sines, that's what that symbol is there, law of sines, you're going to find out that the sine of angle B, which will be the first thing that you try to find, is going to be greater than 1. And you're going to find that, wow, this is just way too big. And so it's not going to work out. Your calculator is going to give you an error when you try to find angle B, which is down here somewhere. This tells you that side A is way too short. It's not going to reach. It can't make a triangle. You don't have a triangle to solve. So there are 0 possibilities on that one. On the second option, notice that side A is the same thing as the height of the triangle. And so what will happen when you go to look for angle B, the very first angle you try to find, you're going to get that the sine of angle B equals 1, which tells us that this is a right triangle. So A is just long enough to reach down here to this side, and it's also going to form a right triangle. So this one's just right. This one's too short. This one's just right. Okay, let's look at the third option. Okay, yeah, that's fine. Let's look at the third option. So notice here, side A is way longer than side B, and I can swing this around all I want to all day long, and it's only ever going to make one triangle. When I apply the law of sines here, it's going to fall within my correct range of values. So I can find angle B. This tells you that it's plenty long enough to form your one triangle. And then let's look at the last option here for the acute angle that's given. Notice here that A is shorter than side B. However, it's longer than the height of the triangle. So basically what's happening is I can swing this side back and forth, and I'm only going to get, I'm going to get a triangle here, but I'm also going to get a triangle here. If I were to color these triangles in, let me go with a smaller size there, this would be one of the triangles that I find, and then this whole entire triangle would be the second triangle that I find there. All right, so those would be the two triangles that I would have to solve. When you apply the law of sines on this one, you'll notice that my range of values is still very good, so the angle B can be found. But then you're going to have to continue to test, and what you'll do is you'll use the supplementary angles to find angle B2. Let's look at why that is really quickly. Notice that if this is angle B1 right here, then this angle in here is the exact same angle. So this angle and this angle, because this is an isosceles triangle, these two angles are exactly the same. When I try to find angle B2, notice that these two angles are supplements of each other. They form a straight angle. So if I just simply do 180 minus B1, I will find my angle B2. So that's what part 3 says there. Not only that, but I also need to test and see if angle B2 works for a second case, a second option. We've got two triangles here to solve. Again, this is going to make a lot more sense when I go and I work through some examples for you. All right, the last two options are for when I have an obtuse angle that's given to me. Angle A is obtuse. So basically what I like to use here is the concept of small opposite small, medium opposite medium, large opposite large. we know that an obtuse angle has to be the largest angle in a triangle. That means that side A, or the side that's opposite, has to be the longest side. So if side A is shorter than side B, there's no way this can make a triangle. If you apply the law of sines to this, what's going to happen is when you try to find angle B, you're going to get something that's too big for the sine of angle B, and your calculator will give you an error. So it's just too short to reach. So then the only other option for when your angle A is obtuse is that side A has to be the longest side. So A is greater than or equal to side B. When you apply the law of sines, you're going to come up with something normal, essentially. And so you'll be able to continue on with that. All right, so I'm going to stop right here. And for the next video, I'm going to pick up again at this gray box. So hang tight and we will